Let's talk about the center of our data. And there's many ways to measure the center of the data. One of these measures of center is the mean. And if we imagine that the data values are weights, then the mean is the point at which the data set balances. It's exactly in the middle. It balances it. Now, recall that we have population and we have our sample. And so when we're talking about number values representing each, we're talking about parameters and statistics. And the notation for each of these is different. So when we're talking about the population mean, the symbol that represents it is the Greek letter mu. And it's kind of like a really fancy M. And the symbol we use for the sample mean is an X with a bar over it. Now, how we calculate these is just like you would think. It's our average, the arithmetic mean. So if we have a list of numbers, this symbol means the sum. So when we do sigma x, that means we're adding up all the x values. So the sample mean, x bar, means we're going to take all those values from our sample and divide by the number we have. So we add up all the values divided by how many we have. For the population mean, again, we'd add up all of our values and divide by the number in the population. And we use little n for sample size, and big N would be our population size. So during a semester, a student took 5 exams. The population of exam scores are these, and we're finding the mean. So this is talking about the population. So our population mean, we're going to add them all up and then divide by how many we have. So if this is the population, we'll be using the symbol mu. And we're going to add up those values. So 78 plus 83 plus 92 plus 68 plus 85. That gives me a total of 406. Divided by, we had 5 of them, divided by 5, and we get 81.2. Now, the next one we're going to look at is called the median. The median is another way to measure the center of data. Now, the median is the number that splits the data set in half, so that half of the data values are less than it and half of them are greater. The procedure for computing the median differs depending on whether the number of observations in the data set is even or odd. Now, if we have an odd number, then the median is just the number in the middle. If we have an even number, then there is no middle number. We're going to average the two that are in the middle. So let's take those same exam scores, and we want to find the median of those scores. Now, to find that middle number, we need to write them in order first. So we would write them 68, 78, 83, 85, and 92. Now there are an odd number, so that means it's going to be the exact middle number. So our median is 83. Whoops, is 83. Start writing an 8 for my S. Now, what if we have 8 patients undergoing a new surgical procedure and the number of days spent is shown, We want to find the median number of days of recovery. So again, we need to write them in order. So we have a 12, 13, and another 13. Then we have a 15, and 19, 20, 21, and 27. So let me double check. I've got 8 numbers. So my median would be in the middle. So I'd have, since it's 8, I'd have 4 on each side. So I'm going to go right in the middle of those 2 middle numbers. So I need to average the 15 and the 19. So 15 plus 19 is 34. Divided by 2, my median is 17. Now we can also do these on the calculator. So I want you to grab a TI-84 calculator if you have access to one. And I'll show you how to do it in there. And I'll also show you how to do it with the NumWorks app. So in the TI, we're going to press the stat button, which is right here. And the first thing we're going to do is press enter, and we get lists. Now, I could delete each of these values just by hitting the delete. That's going to take forever. So if I press the up arrow to where L1 is highlighted and press clear, that's going to clear the list and give me a blank list. And we want to make sure we see L1, L2, L3. If you don't, I can show you how to fix that. But what we're going to do, I'm going to enter in those data values that we had over here, and we're going to double check that we got the right mean and median. So 78, 83, 92, 68, and 85. Now, the next thing we're going to do is do a calculation. So I'm going to press stat again, and then right arrow to calculate. And we have one variable. We have one set of data. So I'm going to press one variable, and it asks, is it in L1? Yes. And we're going to press calculate. And it gives me all kinds of stuff. And here we have a list of what each of these things mean. The X bar is our mean, 81.2. That's the same thing we got by hand. This means the sum of all the X values, and that matches what we had. This is the sum of the squares, and sometimes we need that for calculations. We have a sample standard deviation. We'll get into that later. A population standard deviation, the number of data values. And over here, we have our minimum data value, our first quartile. We'll talk about that. Median, third quartile, and maximum. So let's check the median was 83. That's exactly what we got. Now, so this is how you would do it step by step, entering the data, press stat, go to calc, one variable stats, and we get this wonderful list of all the data. If you are using the NumWorks app, this is in statistics, and you go to the data to enter your data. And I can also clear this one, shift clear. I thought I could. I have to, there's got to be a faster way. I'll find out. I bet if I go up and clear, nope. It won't let me. There's got to be a fast way, but it's pretty fast. This calculator's really fast. So I'm going to type those values in again. It was 78, 83, and I'll just press enter after each one. 92, 68, 85. Now, there's a section that says stats up here, and if I press this back arrow, I'm up into the options, and I press OK on stats, and it tells me the number of data points, the minimum, the maximum. It even gives me some other stuff, the range, my mean. And what I like about this app is that it actually tells you what each symbol means. That's the mean, 81.2. And when I go down, the median, it actually says what it is. That's 83. It gives you a lot of good stuff, and we will talk about a lot of what it's giving you later. Now, When we're talking about these measures of center, there's something that comes up that's really important, and it's called resistance. A statistic is resistant if the value is not affected by extreme values, large or small in the data set. And when we're talking about the difference between mean and median, the median is considered resistant, but the mean is not. And let's show why. Let's say we have 5 families that have annual incomes listed here. And one of those families, the one who has 25,000, wins a $1 million lottery ticket, so their income increases. Before the lottery win, the mean was 38,000 and the median was 34,000. After the lottery win, now we're adding in that $1 million lottery in there. The mean jumps up to 238,000. But the median is 44,000. So that extreme value pulled the mean to the right. It's really, it affects the mean a lot. So the mean and the median measure the center of a data set in different ways. When a data set is symmetrical, so everything is pretty centered. When the data set is symmetrical, basically the mean and the median are about the same. They're going to be the same center. Now, when the data is skewed right, that means we have that $1 million winner over here. That means my mean is noticeably, I can't spell noticeably, noticeably greater than the median because it's been pulled by that $1 million winner. In the same idea, if we were skewed left, had somebody who, only made like $5 a year, which would be dumb, the mean is noticeably smaller than the median. So the mean will get pulled to the tail. Now, the next type of center, another value that we can use is the mode. The mode of a data set is the value that appears the most. If 2 or more values are tied for the most frequent, they are all considered modes. So you could be bimodal, trimodal. If the values all have the same frequency though, then we have no mode, if nobody stands out as the most. So let's say we have 10 students and they were asked how many siblings they had, and we have this list. Find the mode of this data set. So we're looking for the one appears the most. We have 4 ones. So the mode is 1. Now, the mode is sometimes classified as a center, but that's not really accurate. The mode can be the largest value, or it can be the smallest, or somewhere in between. So the mode is usually used for qualitative data, not so much for quantitative. So the mode for qualitative data is the best one. Mean and median tend to be used for quantitative data. So if we had a list of the makes of cars rented by automobile rental company, which make would be the mode. So you would count through and figure out which one is the most frequent. And I believe it is Toyota. You just count.